Okay, in section 5.5 we will look at graphing inequalities and finding the regions for which they are satisfied or not. And all of these are going to go just based on basic graphing techniques. So straight lines, we have a y-intercept, we have a slope, and then we're just going to add a few things to that today. Okay, so we have an equation. Our goal is to get y on one side, some inequality, and then mx plus b on the right-hand side. So the inequalities we could have are less than, equal to, greater than, or greater than equal to. So there's 4 different things that could go in there, and the problem will tell us which one we're using. So here's our first one. We have x plus 5y is less than equal to 5. So the first thing we're going to do is subtract x from both sides, and we will get 5y on the left, less than equal to sign, minus x. We tend to write the x term first, then that 5 is positive, so we write plus 5. Now we have to get rid of the 5 in front of the y. So we're going to divide everything by 5. And we will get y on the left less than equal to, I'm going to write this instead of minus x over 5, I'm going to write it as minus 1 over 5 times x. So there's an understood 1 right there. And then 5 divided by 5 is 1. And the reason I did that is so we can see the slope more easily. So the slope, the number in front of x, is always the rise over run. So this tells us rise, up or down. This would be 1 unit down, and this would be 5 to the right. So run is left or right, positive is right, negative is left. The top number is rise, up or down, so it's positive is up, negative is down. Okay, and then this is our y-intercept. So we start at positive 1. So we put a dot at positive 1, and then we just have to look at this slope. I'm going 1 down, 5 to the right. 1 down, 5 to the right. 1, 2, 3, 4, 5. Or, so minus 1 over 5 is the same as positive 1 over negative 5. So I can move that negative from top to bottom, and then this one is up and left. So, or I can go 1 up and 5 left. And those should line up. Okay, so those dots should be on one straight line, if I've done this correctly. Okay, now we have to analyze what's the inequality mean. So if you have an equal to bar, you're going to make a solid line. And I'll explain a little bit more about why we do that in a future example. So we can just connect all these dots with a solid line. And the less than means that we want our answers to be smaller than this right-hand side. So less than means you're going to shade below the line. Below this line. So in your homework, you're going to see a little paint can. It looks like this little cylinder with a spout on it, or maybe it's supposed to be spray paint or something. You're going to click on that, and then you're going to click anywhere below this line, and it's going to fill it in, because any point in that blue will satisfy this equation. Okay, in fact, let's check that. So let's prove that. So any point I pick in blue should work in that inequality. So let's pick something easy like, well, let's pick 0, 0. So the origin is in this blue. That's the point 0, 0. So let's check the point 0, 0. So x is 0, y is 0, into the original equation, which was x plus 5y has to be less than equal to 5. Now, if these are both 0, I just get 0 plus 5 times 0. Or we get 0 on the left, less than equal to 5. We say, is 0 smaller than 5, which is what this is asking, and you would say, check. That is true. Okay, now let's pick a point on the line. Let's try this point. It is negative 5, comma 2 in the y. So let's check that one. Negative 5, comma 2. Into the original equation and see if we get it to work. So we have minus 5 for x, 2 for y. We get minus 5 plus 10. 10 take away 5 is 5. Is 5 less than or equal to? So the only reason this one works is because this equal to bar. So that says 5 is equal to 5. That is true. Checks out. Okay, now let's pick any point above the region we said would work. So let's pick this point here. X is 0, y is 4. I mean, I can pick any point. Might as well pick a point where one of the variables goes away. So we would check 0, comma 4 is now x and y, and see if that is less than or equal to 5. X is 0, y is 4. We would get 0 plus 20. Is 20 less than or equal to 5? We would say no, that is false. So that one does not work, and so it kind of proves that if we do this correctly and we shade the regions and you pick points in the region, outside the region, or on the line, you can see if it works or not. So that is what we're doing, and we'll do lots and lots of them so you get plenty of practice. But it's pretty much just graphing lines. So a skill hopefully we've been working on since junior high probably, and we're going to see it again today. Okay, so number 10. No different. We have to just move stuff around. So we have 7x minus y is now bigger than 14. And we're going to start by subtracting 7x from both sides. And we will get 7x's cancel. Minus y drops down. Greater than symbol. Write the minus 7x first. Plus 14. Now this is really minus 1 times y here. So to undo that multiplication, we are going to divide. So divide by minus 1, divide by minus 1, divide by minus 1. We will get, on the left, the minus 1's cancel, you get y. Now this is the only rule I have to remember for inequalities. If multiplying / dividing by a negative number flip the inequality symbol. Flip the inequality symbol. So we just divided by a minus 1, so we have to flip this. It goes from greater than to less than. So notice how it switches orientation. And these minuses will cancel, but I'm going to leave this as 7 over 1 times x. And then we have 1 minus here that won't cancel, so it becomes minus 14. Okay, so this slope would be 7 up, 1 right. And we're starting at negative 14. So way down here on the y-axis, minus 14. And we're going to count 7 up, 1 right. 7 up, 1 right. 7 up, 1 right. 7 up, 1 right. So the line's going to look like that. Now, there's no equal to bar. So this one is dashed line. And on your homework, you'll have the option to pick to do the line, and there'll be a little button where you can click dashed or solid. You'll have to click dashed for this one. And so let's see. So to do this dashed, we're just going to have this kind of some gaps in here to show that it's not solid, and I'll show why that is in a second. And if it's less than, just like the last one, we're shading below. Shade below the line. So it's kind of hard to see when this line is almost vertical, because it feels more left or right. But just pick any dot and pick a y value below that. So if this y value is 0, I need to pick minus 1 or minus 2. this y value is -7, so -8 would work, or -9. And then you can kind of see that the answers are, in this case it feels like it's to the right, but it is below this dashed line. Okay, so anything in there would work. Now, why is it dashed? Let's see that. So let's pick one right on the line. In fact, let's pick this right here. That's an x value of 2, y is 0. So that's on the line. And let's plug it into this original equation. So we pick the point 2, 0, which is on the line. So we plug in x is 2, y is 0, and we get 14 minus 0, or 14. Is 14 bigger than 14? The answer is no. So without that equal to sign, this one's false. So in the last one we had the equal to bar and we got 5 equal 5. It was 5 less than equal to 5, so we could use the equal to bar to say, okay, this one works. Without an equal to bar here, 14 is not bigger than 14. So any point on the line, and by the way, you'll get that. On any point on the line, you'll get 14 bigger than 14, which is false. So that's why it's dashed, because we can't let anything on the line be a solution. Okay, now if we were to check in this blue zone versus this white zone, you will get it works and it doesn't work. But I already showed you that once, and so you don't need to do it more than once. You could do that to check your answer on, say, a test or something. It's a nice quick check, but I'm not going to do it for every problem. Okay, so that's number 10. Okay, for a problem like 11, this sometimes throws students off because there's just y and x. There's no number. If there's no number, then that means the y-intercept is 0. So it starts at 0. It has a slope of 1 up and 3 to the right. So we can start counting. 1 up, 2 to the right, 1 up, 1, 2, 3 to the right, 3 to the right. Or, so let's look at this. 1 over 3 is the same as minus 1 over minus 3, so those negatives cancel. And this would be down and left. So I could also go down 1 and 3 to the left. And there we have it. So we have all the dots that you could possibly have with this scale. And we see the equal to bar, so that's going to mean a solid line. So we can just go in here and connect these dots completely. Missed the dots a little bit there, that's okay. And if it's greater than means we want to shade above it. So basically this is saying we want our y values to be bigger than what the line represents. So those points would be anything above the line. So there's a point above it. Here's a point above it. So anywhere in here, so all of this would work. Okay, so that one's not too bad. Just got to plot the line with a 0 intercept right through the origin, and then we are above it because it's greater than. Okay, 12 is very similar. In fact, it's already in slope-intercept form. So we know we start at -1 in the y-axis. And the slope is 2 over 1, which would be 2 up, 1 right. So 2 up, 1 right. Or -2 and -1 would work, which would be down and left. So we could go 2 down, 1 left. And there's your line. And now, because there's no equal to bar, we're going to have a dashed line. As it's a less than, we want to shade below. So a dashed line would just be, leave some gaps in here, so the line itself will not work. And to shade below that line would be down here. So that region is going to contain all the possible answers for this inequality. Okay, number 13, they just give us an x value. So you might recall if x is equal to some number, that was a vertical line. That's a vertical line. So if I have x less than or less than equal to some number k, that's a vertical line, and you're going to shade to the left because you want x values that are smaller than that. You can also have x bigger or bigger equal to some number k, and that's going to be shading to the right. So you want x values that are bigger than the number. So this one says x less than 5. So we go to x equals 5 on the x-axis. We draw a solid vertical line because of that, equal to bar. And because we want x's smaller than that, we're going to shade left of this line. So smaller x's than 5 are x's like 4 and 2 and 0 and minus. So any number to the left of this is going to work. So we take all of this over here. Okay, so not too bad. It's just I find students sometimes forget, what does it mean if I have just an x, no y? That's going to be a vertical line. Okay, then what do you suppose y equaling a number is with there's no x? So you might recall if y is equal to some number k, that's a horizontal line. So again, we can have two possible situations, less than or less than equal to. That's going to be a shade below it. So we've already kind of been working with these. And then if y is bigger than or bigger than equal to some number k, you're going to shade above it. So in this one, we start at y equal to 5. So we go to 5. Now there is no equal to bar, so this is dashed. So you're going to dash this out. So the line itself will not work. And greater than means we're going to shade above. So any number bigger than 5, 6, 7, 8, 9, 10. And notice all these points, so we don't care about the x value. So x over here that's an x value of -6. We don't care about what that is. What we care about is the y value. Its y value is 7. And clearly 7 is bigger than 5. So that point, I would plug in the 7 for y, and it's bigger than 5, so it works. Anything over here would work for this one. Okay, so that's horizontal and vertical lines. They can be a little tricky because we don't see them a lot. So a little bit of a review there. Okay, once we've mastered one line, now we're going to look at multiple lines. So 2 lines, 3 lines, even 4 lines. And they're all going to carve out sections of the Cartesian grid. And then we're going to shade above some of them, below others, and we're going to find these sections of the grid that would work. And I should mention, so these this does actually come up. So like in business, you might want to plot your employees. They make different amounts, and then you might have materials, and you might have several different materials for your product, and each material costs different amounts. You can actually plot these costs with lines like this, and you can carve out spaces in your business model that will work. So you can figure out, okay, I need these employees at these times, or I need this amount of this material, this amount of this material, to minimize costs, to maximize revenue, things like that. So it can be very useful in the real world. All right, so let's break this in. Let's use colors. So we have 2 lines. And we're going to do the same thing. So we're going to get y on one side, x's and numbers on the other, and then we're going to see, is it dashed, is it solid, and then do I shade above or below it. So let's start with 1. We've got 2x plus 4y less than or equal to 4. So we're going to subtract 2x from both sides and get 4y less than or equal minus 2x plus 4. And then we're going to divide everything by 4. So y should be less than or equal to minus 2 over 4x plus 4 divided by 4 is 1. So divide everything by 4. And let's plot this. So we start at y equal to 1, and our slope is 2 down, 4 to the right. 2 down, 4 to the right. 2 down, 4 to the right. Or I can go 2 up and 4 left. So switch those numbers. Switch the minus. 2 up, 4 left. 2 up, 1, 2, 3, 4 left. And this is going to be a solid line because of the equal to bar. So it's going to look something like this. Okay. That's line 1. And we're going to shade below it because it's less than. Now let's look at equation 2. 2x plus y less than or equal 8. And we're going to subtract 2x again. And there is no number in front of the y, so that one's pretty much done. So this one's going to start 8 units in the y-axis, and its slope is 2 down, 1 to the right. So this is 2 down, 1 right. All the way down there, and you can go 2 up and 1 left also to fill that in. This one is also solid. And this one's also shading below it. So let's get the solid line in here. Okay. Now, I want to be below both lines. So I'll put arrows here to show us, okay, that's below it. And then for the green line, below it would be here. Now there's only one region where I'm below both. So watch me carefully. It would be right here. Take this corner. Anything in this region. And it keeps going. But for our grid, we'll just stop there. So anything down there, bottom left corner of this grid, we would have numbers, ordered pairs, that will be solutions to both those inequalities at the same time. Okay, that's 15. Okay, 16 is kind of nice because there's no algebra that needs to be done. We just have to put these in on the chart and see what they're doing. So let's do it. It's 9 up. Actually, let's look at this. So my students in class were kind of stuck here. Like, well, the slope is 3, which is 3 over 1, but I can't go up. So this would be 3 up, 1 right. So if I go up, I'm off the chart. So this is where you have to say, okay, this is the same as minus 3 over minus 1. Because again, those double negatives will cancel. This is 3 down and 1 left. So to get this line right, I need that version of the slope. So count 3 down and 1 left. Okay, and if I did those right, it should line up. Now, there's no equal to bar, so this is a shaded line, or a dashed line. It's a dashed line, and because it's greater than, we're going to shade above it. So let's dash it out. So we're not connecting these dots exactly, we're just leaving some gaps. The line is not an answer. Okay, and we go above it, so we want to have answers this way. Okay, let's look at the second one. It starts at negative 10. Its slope is minus 1 over 1, which would be down and right. But again, I can't go down. So I have to switch the minus sign to on the bottom. Notice that's the same, so it's still minus 1. And now this is up and left. Okay, so we go 1 up, 1 left. Okay, and then this is also dashed. So this is also dashed. And now this one wants us to shade below. because of the less than. So below this would point down. And again, the only region that has both arrows pointing in a similar fashion is this chunk right here. So anything in here would work for both equations, inequalities. Okay, so that's 16. Okay, for 17, it's really not bad. If you remember, x is a vertical line. It's solid. And because it's smaller than, we're going to shade left. So we're going to go to x is 9 right here. Do a solid vertical line. And we want to shade to the left of it. Okay, equation 2, y bigger than, this is a horizontal line. It's also solid because of the equal to bar, and because it's greater than, we want to shade above it. So we go to y equals minus 5 right there. We do a solid horizontal line, minus 5, and we want to be above it. So you can see that this carves out this box right here. So anything in there will work for both of those inequalities. Okay, so it should be a pretty quick problem if you remember vertical and horizontal lines. Okay, for 18, they want us to, they've actually already given us the picture, and all the pictures as far as the lines are concerned are correct. So they use this violet or purple color for 1. So you would just have to subtract x from both sides and get this. Now this is a dashed line, and they want us to shade above it. Okay, so all of these do start at 6. So they start at 6, and they have a slope of -1, which is 1 down, 1 to the right. So all of these, the dashed violet line is correct. Now let's look at 2. They did 2 in blue. So y, again, subtract x from both sides. Minus 2, this is also dashed. But because it's less than, they want to shade below it. So these all start at -2, and they all have a slope of -x. So notice when they have the same slope, so this slope of -1 and -1, those slopes are the same, you get, you might remember this, parallel lines. And that's what we have here. So they look like train tracks. But here's the thing. They want us to shade above the purple, or violet, whatever the color you want to call it, and that's the key word, and below the blue. So, but you have to ask yourself, can one point be at the same time above the purple and below the blue? And hopefully you would say that's impossible. So one point can't be both up here and down here. So the answer is actually no solution. So if you look at each of these, they get the shading wrong. So this one would have been below purple and above blue. That's the opposite of what we have. This one would have been above both. This one would have been below both. And then this one's the only option that works. There is no solution. Okay, then the last couple are going to be multiple lines, more than 2. So we'll do one with 3 and then one with 4. So let's number these, and then we will look at each. Okay, so let's start with 1. We have 2x plus y has to be less than or equal to 4. Subtract 2x from both sides. Y has to be less than or equal to minus 2x plus 4. This is going to be solid, and we're going to shade below it. So we start at 4, and the slope is 2 down, 1 right. Or, going the other way, would be 2 up, 1 left. And it's solid, because of the equal to bar. So we can just connect these. A nice smooth curve like that. Smooth line. And go to number 2. So number 2 says x has to be bigger equal to minus 6. This is a vertical line. It's solid. And we're going to shade to the left. Oops, excuse me. It's bigger. Bigger than minus 6. So we're going to shade to the right. So we go to x is minus 6, put a dot, solid vertical line through that, and we want to shade to the right. Let me put in the green also. The green said shade below, so we're going to point down. Okay, last line. 3. Y should be less than or equal to 4. This is a horizontal line. It's also solid. And less than 4 would be below 4. So we go to y equals 4. We draw a solid horizontal line, and we want to be below that line. And hopefully you can see there's only one region out of the 4 that's carved out where we have all the arrows in agreement. They're all pointing towards a similar spot. So that area there would suffice, satisfy all 3 of those equations at the same time. So any point you pick in here, if you plug it back into these 3 equations, you'll get true, true, and true. So they'll all be true. Okay, last problem in this section is 4 lines. So we have line 1 would be subtract 5x from both sides. Y has to be less than or equal minus 5x plus 10. This one's going to start 10 units up. Slope of minus 5, which is 5 down, 1 right. And it is solid because of the equal to bar, and we're going to shade below it. So we have solid line, and we're going to shade below it. So that direction. Line 2 would be subtract 2x from both sides. Now, let's be careful on this one. To get rid of that minus y, we're going to flip everything. So y minus y becomes positive. The sign flips. Negative 2x becomes positive 2x. Minus 1 becomes positive 1. So this one's also solid, and we're going to shade above it. Because we flip the sign because of the negative. And so now it's above. We want to shade above. So we start at x. Y is 1. The slope is positive 2, so 2 up, 1 right. 4, 2 down and 1 left. And this one's also solid. Okay, and we want to go above this line. Okay. Line 3 is x bigger than or equal to minus 3. This is a vertical line. It's also solid, and we want to shade to the right of it. We want bigger numbers than negative 3. So we go to 1, 2, 3, draw a solid vertical line, and we want things to the right of this line. Last line, 4, y should be less than or equal to 6. This is a horizontal line. It's solid, and we want to shade below it. So we go to y equals 6, right there. We draw a solid horizontal line, and we want to go below it. So it's a little bit hard to see with all my arrows, but if you look at this sliver here, and be careful, it has these 2 corner points here. This is the region where all those arrows are pointing. So that's the, now it's just coincidence that both of these last two examples had the dead center kind of region. So you do have to, just carve it out and see where your arrows are pointing and where they're all kind of combining together in one spot. That is where your solution lies. And that, any point you pick in that region there will satisfy all four of those equations at one time. So that will complete section 5 here.